See if it's recording. It is recording. Woohoo! Okay, so there you have it. It's recording. We finished all the descriptive stuff this morning. This afternoon we have something, EFA. Oh, and did the folder sync? It isn't. Let me try this again. Retry all. I might have to just quit Google Drive. Yep, let me quit Google Drive. It says it's syncing, but I think it's been saying that all morning. Let's try this. Quit Google Drive. Should be quitting. Come on, quit. Thinking about it. Well, we can force it. Google Drive. Chrome. Google Drive. Here we go. End task. Go. Google Drive. See if this does it. This one's actually syncing. There we go. That one's still dead. There we go. Preparing for sync. All right, so this should sync. There we go. It's syncing 288 files. Oh, it's been a while. All right, so this should upload, and you should have access to everything we did this morning, including all the data sets. I saved all the data sets and the slides, so you should have access to those as soon as this is done syncing. Sorry about that. Sometimes Google Drive just stops for some reason. Okay. So this afternoon, EFA. I want you to do your best to stay awake even after that tremendous lunch. I had apple pie and eclairs, and I'll be all right. I go there 3 to 4 times a week. That's how I keep up my figure. Let's see.
He's the teacher right now.
Yeah, no mutiny yet. It's the gymnastics. Gymnastics and 4 daughters. Yeah. It changed. Woo! It's updated. Okay. Good. Wow, that was fast. Excellent. So you should have the slides. They should say updated May 1st, 2017. I mean, yeah, on the front slide. Yeah. So I'm supposed to remember to tell you, because I forgot, that I offer a certificate if you go through this whole thing without any troubles. If you don't quit halfway through. This is useless to faculty, but if any students need it to either get funding for their travels or like justification for being here, or need it to somehow certify for something, I'm happy to give out a certificate that says, so-and-so successfully completed the SEM Bootcamp 2017 held at BYU. It looks almost official. I didn't even Photoshop it. I just like Adobe PDF'd it. I think I did it in PowerPoint. That's how bad it is. But it has my signature on it, which you can cut and paste anywhere. Just kidding, please don't do that. But if you want that, email me individually and tell me you want it. Please also include the full name you would like on there. I will put any name on there you want. It could be like president, whatever, chief mugwump, whatever you want, I'll put on there. It means nothing to me. I mean, okay, but if you need that certificate, let me know, and I'll get that to you after the boot camp's over. It has been helpful for even junior faculty to get travel reimbursement. Okay, so I want to talk to you about measurement models versus structural models. So this here is a causal latent model, or latent causal model, however you want to order that. The latent part is this, I should show it. I should be on here so everybody can see remotely. The latent part is this oval, these ovals. There's no number behind that oval. It's a trait we're trying to capture, and the way we capture it is latently. Hidden is what latent means. And these items, these rectangles here, represent the survey questions we gathered data on. Now, each of these actually have numbers. They're called observed variables, whereas the latent is called an unobserved because there is no number for it. Using the numbers from these observed variables, we can infer a number for the latent variables. And then we say this trait or construct or factor, whatever you want to call it, this unobserved variable here has some effect on this unobserved variable. But again, it's all latent, happening through the observed variables we've collected. And the mathematics behind it, you don't need to worry about it, but essentially it's a weighted average. And the weights are regression weights. We saw regression weights in the last session when we were looking at the beta coefficient. Okay, so you'll hear the terms measurement model. That is the latent to observed relationships, how something is measured. That's the measurement model. Then you'll hear the word structural model. That is the relationship between traits or constructs. The way you build a structural model can vary. You can use these latent factors, or you can actually draw lines between observed variables, and that would be a structural model. Anything that is a relationship between variables would be structural. Causal relationship between variables. So that's a structural model. You also hear the terms path model, SEM, multiple regression, multiple linear regression, MLR, all of these things referring to the structural model. Okay, and all these things on the end, these are error terms, E9, E8, these are error. We talked about the variance that is captured when we take surveys or collect data. That's that piece of the variance. The only piece of variance not captured here is the method variance. And there are ways to capture that, which we'll talk about tomorrow. There are a couple different kinds, or a few different kinds of measurement models. One's the EFA, the Exploratory Factor analysis. It's unguided. It's like throwing a bunch of survey questions on a canvas and seeing how they stick together. There's confirmatory factor analysis, which is guided. It's where we say, well, these survey questions belong to this trait, and these survey questions belong to this trait, and they're all related in some way. Very guided. Then there's multi-trait, multi-method. I'm not going to teach about that, but essentially you're saying this item belongs to this trait, but it also belongs to this method. And you're giving one item multiple latent factors belong to. And there's hierarchical CFAs. We might touch on that if we have time. That's where you have higher order factors. So you can say, here are two latent factors, but these two things belong to this higher thing. So it's what's called a second order factor. Talk about that a little bit. There's also hierarchical modeling, which is different than this hierarchical CFA. We won't even get into that, but it's essentially I have individuals who are part of groups, who are part of teams, who are part of departments, who are part of organizations, who are part of industries, who are part of regions, who are part of the world. You have this hierarchical way to structure data, and there are ways you can analyze data using those hierarchies. But I'm not going to touch that in this class. There are also linear growth curve models, lots of others that are not going to be talked about today. Okay. EFA versus CFA, because these are the ones we're doing, EFA and CFA. Today, EFA, tomorrow, CFA. Exploratory factor analysis. I get questions every week about this from people all over who say, hey, I'm using scales that exist. I didn't make up any of my own scales. These are all survey questions that other people have used and validated. Do I have to do an EFA? The answer is, yeah, you should. I mean, you don't have to, but you should. It's like, do I have to filter my water? You know, people have been drinking this water in Ghana or wherever for centuries, and they haven't died, all of them. So do I have to filter my water? Yeah, if you go to Mexico, filter your water. That's what EFA is for. You don't have to. You'll get sick if you don't. If you're American. Okay. Or not Mexican. I'm speaking from experience. Yeah. There you go. But the answer is, even if other people are doing it, it doesn't mean, or not doing it, doesn't mean you shouldn't do it. The exploratory factor analysis has so many advantages over the confirmatory factor analysis. The main advantage is that it's unguided, and so it surfaces all of the problems with the data. Whereas the CFA, because it's so guided, those problems sometimes stay below the surface and you don't catch them. Confirmatory factor analysis, when should you do this one? Always. You got to do it. So do it. Here's sort of visually. EFA, you literally just throw all of your items at the processor in SPSS and let it determine how they're related. You give it no guidance whatsoever. Whereas a CFA, you tell Amos exactly how things are related. You draw it how they're related, and it says whether or not you're correct. We sort of talked about this. Items are literally things from your survey. Here are the numbers come in. Person number 251 said on this question, a 5, strongly agree, right? That's how we get that data. That's how it's organized. And then we collapse, we take multiple items and they form the traits or constructs we're trying to capture. And that should be a review there. It's just a bunch of information. What I'd really like to do, again, the slides are for your information. Even put FYI on them because I didn't want to go through them. And I want to just do it and talk as we go through it. And then you can ask questions as we go. And then I'll go back to the slides and see if we missed anything. So. Yes. There's an error in the slides. Oh, you can't download it. Name of it is, you're not even on a Mac. Huh. Oh, you probably downloaded the wrong piece. You're downloading a temp file. Yeah, don't download the temp file. Go to your folder. Here, I'll show you. Multiple people might be having this problem. Mark's got you covered. Mark, thanks. Oh, you did figure it out?
Yeah, no, yeah.
Oh, okay.
It was just the 2 of them.
Oh, yeah. Thanks. Okay. Yeah, don't worry about it. Good. Cool. Here we go. EFA. Boot camp. Same data. If you want to follow along using this data is now available for you. It is in that folder. So you can go download that folder or file, excuse me. Here we go. We've got everybody here. Good. No chat. For the factor analysis, I'm going to go to analyze. Dimension reduction, because what we're doing is we're reducing complexity. Dimension reduction, factor. All sorts of other things here. I've always wondered what would happen if I clicked one of them. Yeah, it might explode. Yeah, not right now. Yeah. Okay. I now and then do click on new things, and it's fascinating, all the stuff you can do in here. So we want to do a factor analysis on all of the reflective latent factors. Again, I use the word reflective. We'll talk about reflective formative later. But again, that means interchangeable indicators. We don't want to throw social desirability in there, or at least we don't have to. It's a control variable. I'm not that interested in it. And even if it fails, I'm just controlling for it. I'm not terribly interested in it. So I'm going to take out social desirability. So we have in here anxiety, comp use, playful, information acquisition, decision quality, and usefulness, with a lot of redundancy built in. You can see we have so many items for decision quality and for useful. In descriptives, let me zoom in. You can find this in all my videos, what to click and what not to click. You can click all sorts of stuff, see what happens. I'm going to click on reproduced and KMO. But there are other things here you can click and get more information from, but these are the ones I feel are necessary for what we're doing. And then that was in descriptives. In extraction, there are a bunch of different methods here. I prefer maximum likelihood. It's very strict, and it surfaces issues pretty well. It's also the same algorithm used in Amos during a measurement model. And so it's consistent, the SPSS to Amos. I'm going to use maximum likelihood. If you're not getting what you want, you can switch over to principal components, which is the least strict, and that should give you easy results. So maximum likelihood for very strict. I'm going to go ahead and check the scree plot for now, just for video. Principal axis factoring is good for, sorry? For K-clusters, for formative models, you can use it, although I hate doing formative EFAs and SPSS. Yeah, it's the oblique factoring method. Okay, so but I'm going to use maximum likelihood for this one. We assume maximum likelihood assumes that your factors are related to some extent, and ours are. So. The eigenvalues, we might come back to this. Is there an eigenvalue sign? Yeah, sign. Yeah. Okay. Now, eigenvalue is essentially the value, the worthness value of a particular factor. What value is it adding? But we're going to leave that at 1 and hit OK down here, continue. And then rotation, a bunch of different rotation methods. I'm going to select Promax. Why? Because I said so. The most popular is actually Varimax. Most people use Varimax. It's a very loose, liberal solution. Promax is a little stricter, but comes out with good discriminant solutions. I like Promax. Continue. Scores, just skip scores for now. We'll come back to this. Options. I'm going to suppress small coefficients. It's going to make our results a lot prettier, a lot easier to read. I'm going to suppress them at I'm going to do 0.3 for now. Why? Because I'm hoping all my loadings, meaningful loadings, are going to be above 0.5. And I want there to be a difference of 0.2 between my meaningful loadings and my unmeaningful loadings. And so 0.3 to 0.5 is 0.2 difference. Sorry, that's too much detail. It'll make sense later. So trust me on this one. This is what I call the TurboTax part of SEM. This is where you point and click and check all the boxes I tell you to, because I told you to. And trust me for later. Okay, continue, and that's it. And hit OK. And I'll zoom out. All right, we have chat here. Let's see. Could you increase the size of your display at all? I'm having a really hard time seeing, even when I use full screen. Even when I zoom in? Really? Do you wear glasses? Really? You must have a really small screen. Good question. So no, I can't. Well, I can, but it would really ruin the resolution, the grand fineness, precision of the visuals. That'd be hard to read for everybody. Do we throw categorical scores in EFA? No, do not throw categorical variables in EFA, period. Categorical variables, the EFA is built on the covariance matrix. For something to belong in a covariance matrix, it needs to have meaningful movement in its variance. But as you move up and down a categorical scale, let's take marital status, for example. Let's say 1 equals single, 2 equals married, 3 equals widowed, 4 equals divorced. As I move up that scale, do I have more marital status? No, that doesn't make any sense. Just because you have a 4 and I have a 2 doesn't mean you have more marital status than me. So the movement along that distribution doesn't mean anything. So don't throw categorical variables in there because the EFA is based on that movement, that covariance. Can we expect very different results in CFA whether we're using, for example, PCA? Yeah, the different rotation methods and extraction methods will result in different factor structures. Hopefully not terribly different, but somewhat different. Okay, don't load moderators, controls, or multigroup yet. Yeah, somebody asked, should we put in gender? No, gender's categorical, so don't include that. Experience is a single item, it's not latent, so we wouldn't include experience. Again, only things that are part of reflective latent factors stick in EFA. Just your IVs and DVs that are latent. Yeah. And mediators. And controls if you want to, although those are less critical to include at this point. What if my moderator, high versus low, is measured in a Likert scale? Ooh. If it's high versus low, that's a really short Likert scale. It's 2 values, so it's not. Also, if you have a binary variable, it's not part of a reflective latent factor, guaranteed. Okay, so here we are in the results. I will zoom in so that everybody can see it. Lots here. That's why we have all afternoon. Lots of numbers. The KMO, well, let me back up. In an EFA, the reason we're doing an EFA is because we have all these items from the survey that are supposed to measure 5 or 6 different constructs. But we have 60 or 40 or however many items. We need to find out how these items cluster and if they cluster well and if they cluster separately. Or do I have 2 constructs that have items that cluster in an overlapping manner? And if so, how can I distinguish those clusters? And so that's what this does. It also shows the extent to which my variables even relate to each other. In fact, that's what the KMO is for, is how well are all my variables related. This 0.918 says they're very well related, highly related. Anything over a 0.7 here is fine, but typically you want to see 0.85 and above. It can get down to a 0.5, and the guy who wrote the paper on this said that that's miserable. That was his word. Anything at 0.5 is miserable. Anything at 0.6 is mediocre. Anything 0.7 is middling. 0.8 is meritorious. And 0.9 is marvelous. Yeah. Oh yeah, marvelous, marvelous. The sig value here means that our variables are related to each other, and so they can be factored. Jump down to the communalities table. Jump down to the communalities table, and we're going to look at the extraction column. Now, extraction column doesn't come out in every type of rotation, so you might not see that if you're using a different type of rotation. But we're looking for numbers here above 0.3, and we're looking pretty good. There's a 0.36, 0.306. That might end up dropping. These numbers are the extent to which that variable relates to other variables. We want them to be related so that they can group together. It's essentially the stickiness of the variable. If you throw a bunch of stuff in a barrel and it's not sticky, it won't stick together. The covariance, their communalities, is that extent of stickiness. Okay. Next table is the total variance explained table. This will show you how many factors actually got extracted. We wanted 6. We had 2 IVs, 2 mediators, 2 dependent variables. So we wanted 6 factors extracted. We got lucky and got 6. Wow. And if you look at this cumulative percent column, it shows this is like an R square for the whole factor analysis. It says that we can explain 62-ish% of the variance in these variables by grouping them in this way. That's pretty good. You want something above 60, so we just beat that. That's the ideal. If you get above 50, that's still better than nothing. Right? Any less than 50, and you start worrying your variables aren't very good for factoring. The moderator was a single observed variable. Yeah, so it wouldn't belong here. Cool. So we're good there. Scrolling down. Here's the scree plot. Might need to zoom out. Well, that'll do. Here's the scree plot. This plots the eigenvalues, the value of a factor. So how many factors did we have? We had 6, which means it cut it off right here. Why? Because 1 runs right there, right below that 6th dot. And so just a plot of eigenvalues. Typically, you want to look at the elbow here. Wherever the biggest elbow is, that's where you should probably have cut it. And that is where we cut it. We cut it at 6. This elbow here shows there's not a lot of added value beyond this 8th one. So here's the 7th factor right here. It adds barely any additional value above 8 factors, which adds barely any additional value below the 9th one, and so on. But the sixth factor adds a lot more value. And the fifth and fourth and third and second and first factors all add a ton of explained value, essentially contributing to the R squared of the whole model. So that's what eigenvalue is. Okay. Ignore the factor matrix. No one really knows what it means. Okay. If you do, let me know, because I always just ignore it. If you figure it out, let me know. This next table is massive. It's a big matrix, but you just want to look down at the bottom. What this is it's a model fit matrix. It's taking the covariance matrix and contrasting it with another matrix, the observed matrix, proposed matrix, and it's trying to find the difference between these two matrices, and the distance between them, the difference between them should be small. Why? I'll talk about model fit tomorrow. But we want a small number here. 4%, fabulous. 5%, fabulous. Anything above 5%? Okay. Above 50%? Ooh, very bad. Okay. Pattern matrix is the bread and butter of the EFA. This is where you want to keep coming back to. So here's the pattern matrix. It might be called the rotated factor matrix if you're using PCA or PAA. Rotated components matrix, PCA. Rotated factor matrix in PAF. But this shows where the groupings are, how things stuck together. So as you look at anxiety, these are the loadings. You can think of these like coefficients. They go up to 1. Anything above 1 is an error. It's a mistake in calculation. I call it Haywood case. But they can be anything between negative and positive 1. We want them to move together in the same direction, so all positive or all negative. Typically, we look for positive. And the higher the loading, the better. In this case, the loadings are all above 0.6, which is great. We want them to average out above 0.7. Why? Because of AVE, average variance extracted. It's a number that we say has to be above 0.5. You square it. Don't worry about it. I'll talk about it also tomorrow. But it's for convergent validity's sake. Higher numbers are better. So in this case, yeah, we average out above 0.7 easily. So look at compuse. We average out just above 0.7. So that's pretty good. Look at playful. Here's playful. And looking pretty good. Yeah, we average out above 0.7. And everything's above 0.5, which I like as a sort of a low-end threshold. Ooh, we have problems. Information acquisition. All low, all below 0.7. So we need to go fix that. We'll do that in just a sec. And decision quality. Look at this, estimation error, Haywood case. Also a 0.388. Ugh, that's yucky.
So is this similar to the Cronzbach alpha in other tests?
Somewhat. No, well.
I mean, kind of, sort of?
Kind of, sort of. We're actually going to do a Cronbach's alpha right after this.
Okay.
Yeah. Okay. Sorry, I'm going to. Yeah, what was your question?
It's pretty rude.
Yeah. What's that? As an average, I'm using 0.7. So according to Hare, Joseph Hare, he says if you have a sample size over 300, you can have a loading as low as 0.35. So we're good, right? But 0.35 is really low. I really hesitate to keep anything below 0.5 because it brings that AVE measure down in the end, and AVE is a pretty strict cutoff for convergent validity. And if we don't meet it, we have problems. So decision quality has issues, information acquisition has issues, usefulness is awesome. We only have 2 problems. Let's isolate those problems and fix them on their own. So I'm going to zoom out. Oh, a bunch of chat. Here we go. What if my moderator, nope. What if we have items loading high on factors but low on communalities? Oh, that's an interesting scenario. That means they move together but not with anything else. And what if you have that? Well, then you might have difficulty predicting anything with anything else. It means that factors aren't related to each other, which means their regressions are going to be low when you start doing the causal model. What if moderator is unlickered? Should we include it? Yes, if it is reflective. What happens if you get 8 factors instead of your original 7? Ooh, good question. Let's say we wanted 6 actually, and we got 8. What do? I need a messier set of data for this. Tell you what, we'll get to that. Remind me at the end of this, let's do a messy EFA. Let's do a bad one, and I'll cover that when we do it. Oh yeah, it could be a clean 8 factors. You could add a factor. It depends on your intent. In your hypothetical scenario you're currently engaging in, the capstone, I would not add factors. Yeah. So what if you have a factor that comes out with just 2 loadings, and they're good loadings, but it's an unexpected factor? Do you keep it? Well, if it makes good sense, you go look at the wording of those 2 items, and if they have a common theme, sure, why not? Unless it's redundant with another factor you already have that's stronger. We might run into that with a messy EFA. Hopefully we will. When you first started, what did you pick under descriptives and also under extraction? I missed it. I'll do it again, don't worry. Negative correlations make sense in that table? Yes, only if they're all negative. You'll also see a negative mixed among the positives if you didn't reverse a reverse-coded question. So, does that mean I can combine the one factor that's split? In an EFA, you can't, because you can't force it to belong to that factor unless you force the number of factors. And even then, it's just still based on the statistics, the covariances, and so it may go somewhere else. All of these issues will be addressed when we do a messy EFA. Lots of contingencies there. Squiggly face. Yes? Yeah. Way more than we need. Yeah. So different schools of thought on this. The question was, we have so much redundancy built in. Look at this. We have like 8 items here, 7 items here. Does it make sense to bring it down to the ideal number of 4? And the answer is, statistically, yeah, it makes a lot of sense. But traditionally, conventionally, people don't. They like to keep the whole scale together. Why? Because people are irrational. I have no idea. I would keep it. Keep it all together. Yeah. Unless it deserves dropping. Like up here, we're going to see. Let's go do the decision quality versus information acquisition, just those 2, and you'll see there are some that probably deserve dropping. Okay.
What I see on that is the scale in the first place often tests it very well with a nice wide sample.
Oh, yeah.
A very valid situation. And people that borrow that scale often don't have that same quality of sample. So they default back to, well, this is what they said. So
yes. For those remotely who didn't hear that, very good point. Typically, I actually got this email this week. The guy said, I'm using a scale that has been validated in the literature. The guy who made the scale, it loaded beautifully, and mine is failing. I asked about sample size. He had like 80 sample size versus the guy who originally tested it had like 600. And the population was probably better, like Mark was saying. So what do? Well, it's better to clean a bit. Is 1.00 a Haywood case? Yeah, well, I guess technically no. It could go up to 1. It means perfect shared variance. But we will fix that, don't worry. Okay, let's do this thing. We're going to, before we do just an EFA with those 2, we're going to do a Cronbach's alpha with those sets of scales. A Cronbach's alpha, if you go to Analyze, Scale, Reliability, Analyze, Scale, Reliability, we're just going to go straight down to Information Acquisition and Decision Quality. Here it is. These guys right here. Just information acquisition, I'm going to throw in there. It's So this is analyze, scale, reliability analysis here, throw in information acquisition, and then in the statistics options, check this box for scale if item deleted. What that's going to do is it's going to show you the Cronbach's alpha if you deleted an item. How would it change? A bunch of other cool things you can test here. I'm not going to right now. I'm going to continue and hit OK. And it comes out with, here's my Cronbach's alpha. Let me zoom in. It's a 0.837. We want anything above 0.7. So this is good. This is actually really good. But can it improve? The answer is yes. Look, information acquisition 5. If we delete it, our Cronbach's alpha will improve. If we go look at our pattern matrix from before, information acquisition 5, 0.47 versus all these others. It's the one that's not clinging to the rest of them. So we can delete that. Let's look at decision quality. So we're going to do reliability analysis again. Look at decision quality. 6 through 13. Okay. And 0.903. Beautiful, beautiful. Could we improve it? Yeah, get rid of decision quality 13. Now, typically, I wouldn't say you need to improve a 0.903. But we're trying to fix this scale, so that might be an option. And it's decision quality 13. Again, if we went back to the pattern matrix, decision quality 13 is a 0.495. It's one of the lower ones. Look at 0.388 for decision quality 11, though. Let's do this. That was just to give us clues. Let's do an EFA one more time. But this time, get rid of everything except those 2 factors. And also, do this. This is fun stuff. Go to the rotation and click on loadings plot. This is going to create a 3D, it's just 2 in this case, probably a 2-dimensional plot of where the items load. And you'll get to see visually how they're loading. It can go up to 3 dimensions. Our brains can't handle 4 dimensions. Okay. How many came out? So let's just jump straight down here. 2 came out. We were expecting 2. We only had information acquisition decision quality. We scroll down. Scree plot. Yep, sure enough, 2. Skip the factor matrix. Look down at the bottom of this reproduce matrix. It's bad, 14%. Look at the pattern matrix. Here are the loadings. Let's see. That's not too easy to read. Let's scroll down to this right here. The factor plot in rotated factor space. So this shows us how things are loading together. You can see 11 and 13, they were the low loadings before, right? They're over here, while the rest of it is over here. They're also closer to information acquisition. We want to separate information acquisition from decision quality. So what I would do at this point is I would get rid of 11, because it's the closest here, maybe 13, and maybe 5. But let's start with just 11 and 13 and see if that fixes the whole problem. 8 is also over here. We'll see what happens. I'm going to start with 11 and 13. So let's redo the factor analysis. Just the same one. Get rid of 11 and 13. Keep 5 for now, information acquisition 5. Run it again. And I'm just going to jump straight down to that plot. See if we were able to discriminate a bit more. You can see separated loadings now. If we go back up to the pattern matrix, let's see how we look. Whoa, actually didn't expect that much of a change. Information acquisition, those jumped way up. That's way better. Decision quality, those are better but not perfect, but it's above 0.7 average. We're probably good right there, actually. Right there. We separated them, and by separating them, what happens is when you have 2 factors that are closely related due to a couple items, the shared variance between those closely related items pulls away explained variance within the factor. And so the loadings on the factor will be low because they're shared with another factor. as soon as you separate those two plots, those two groups of items, that variance that was explained by the other factor is now brought back home to its home factor. And so the loadings are allowed to increase. Okay. Okay. So let's run the whole factor analysis just with those two items missing. What would you report? You'd say, we ran the factor analysis. We found that decision quality 13 and 11, two items for decision quality, didn't load well and were causing discriminant validity issues and convergent validity issues. Therefore, we deleted them, which was also fine because there were 7 of them or 8 of them, and we only needed 4. And we ran the Cronbach's alpha, and it was revealed that those two items actually decreased the Cronbach's alpha. Yeah, it was. Oh, and yeah, more justification. Did we find kurtosis issues with information acquisition? Oh, I wonder if it was. Yeah, I have the Excel table right here. Let me see. Decision quality 7 was a problem. Information acquisition 3. So nope, those weren't the problem ones, but that's all right. That was education. So, right, so back in our descriptives, we found kurtosis of 2.5, which I said, not a big deal, but let's flag it and look later. This is a time to look later. And we go look at the communalities. Are they bad? Or we go look at the loadings. In fact, let's just go look at acquisition 3. Here's info acquisition 3, strong loading. In fact, the strongest of my loadings. We go look at the plot down here. Let's go find 3. 3 is right here on the edge. It's the highest loading. Upward is higher in this case. So, and on the rightward is higher. So it's doing good. Like I said, the kurtosis, as long as there's sufficient variance, 2s don't bother me. It's when you start getting over 10, it's like, whoa, that's really high. Especially if there isn't any variance being observed. Okay, there was a question over 6 questions. Okay, sorry, to understand it, Claire, you said, let me just make sure. Yep, okay. You said EFA is only for reflective items. If every set of questions are composed of 4 items, 100% interchangeable. Not 100% interchangeable, but highly interchangeable. Yeah, the EFA in SPSS is primarily for reflective latent factors. Why do I say that? Because it's built on the covariance matrix, and reflective items are meant to covary, whereas formative, which again we haven't really talked about, there's no assumption of covariance in formative indicators. Reflective items are items that are reflective of the construct, versus formative items which form the meaning of the construct. I meant construct item. So separate loadings is what you want or want. Separated loadings. Yeah, in the pattern matrix, you want groups of loadings. If we had multiple groups of loadings on the same factor, that would be a problem. We have individual groups of loadings on each factor. Or if we had an item loading on multiple factors, that's a problem. You go over the Cronbach's alpha again. Yes, the Cronbach's alpha is a measure of reliability, the extent to which the movements of the items are consistent with each other, which means low error. So Cronbach's alpha means it is a reliable, air quotes, reliable construct. What is the difference of structure matrix and pattern matrix? I'm not sure. If you figured out, let me know. But I use the pattern matrix. Okay. Let's run that EFA again. Factor analysis. We've gotten rid of decision quality 11 and 13. Let's put everything else back in. So again, that's everything except social desirability and those 2 decision quality items, and then all those other individual items there. Yeah, and let's review the settings because more than one person asked about that, yeah. In descriptives, I've checked the box for reproduced and KMO. Initials default checked. And hit continue. In extraction, I've selected maximum likelihood, but you can select something else if you really want to. I also selected the scree plot, but we don't need it anymore. And I'm doing it based on eigenvalues. Let's say you ended up with, you wanted six factors, but you ended up with 8. You could actually fix it to 6 right here. Say, give me 6 or give me death. Yeah. Okay, but I'm going to change it back to eigenvalues. Why? Because 1 is a proven value threshold that works for factors. Yeah. It's when you're fitting an artificial model. So our natural model based on eigenvalues is 6. Let's say it was 8 and we wanted 6. As soon as we constrain it, what we're doing is we're forcing it to fit our proposed model, which immediately inflates the chi-square, which is a measure of model fit. It immediately separates, creates distance between the observed pattern matrix, or the observed covariance matrix, and what we're proposing. We shouldn't fix it that way. We should fix it by fixing the items. So in this case, we fixed it by deleting 2 items. If you do fix it to a specific number, you will find later on down the road, like in the CFA, you will come across problems, particularly discriminant validity problems, because it wants to have a separate factor, but you're pushing it into its own factor. Yeah, also convergent problems because it doesn't belong in the home you're putting it in. DJ. Mm-hmm. Let's do something. Those remotely, I'm going to repeat what DJ just said, but with pictures. Okay. So you theorize this. You have a model in mind. When you're collecting data, you have some idea of what you're going to test, right? You have a theory. And so you put together a survey that captures each of these, let's say with 5 different survey questions. And here I have trust, loyalty, sales, reliability, and satisfaction. But when you collect your data, this is what comes back. Each of these dots represents one of the survey questions. Their distance toward their closeness to each other represents their strength of correlation, essentially their R coefficient. And so when we collect that data, we find out we didn't test that beautiful model. We tested this model where, what is it, loyalty is all over the board, and so is trust. And in fact, these factors aren't separate at all. In fact, so when we do the EFA, we see this. We see that we ended up with 2 factors instead of 5, or we ended up with 8 factors instead of 5. So what we should do, the reason we do the EFA is so that when we end up with this mess, what we can do, is we can identify groupings that didn't exist before, like this one. That's a tight set of dots there. Those are tightly related items. It's essentially what you're saying you're running into. You ran the factor analysis, and you came up with all the factors you expected, and then another. Or maybe you missed one, like this one, reliability here. It didn't pan out, period. Like all of its items were unrelated to each other, but they were related to other things, like this guy right here. Yep. So in your particular situation, so for the rest of the class to get in on this hidden conversation, the DM students from Case Western are doing a capstone exercise that I'm not allowed to answer questions about. But we're not. I'm not. They're asking me hypothetical questions right now. So, in a situation like that, if a new factor emerged, in your particular context, let's say you had a theory you wanted to stick with, you're sticking with that theory, which you're supposed to do for this exercise. You would say another factor emerged, which we dropped because it was not part of the theory we were given. You got to back up why you dropped it. Yep. Yeah, 3 or 4 items per factor would be nice. Minimum of 2. Okay. Oh, it's fully redundant. Yeah, just drop them. Sure, definitely. In a reflective construct, yeah, you're more than welcome to drop a few. You have so much redundancy. Some people may say it's willy-nilly, dropping items left and right, but there's so much redundancy built in. Yeah, it's hard when it's your own, and it's hard when it's your advisors. And I'm curious what the translation for willy-nilly is. Willy-nilly, that's cool. All right. Okay.
One question, please.
Yes.
So,
Did you just
how do you determine which data analysis technique that you want to use? For example, what's the difference between covariance-based structured equation modeling and using smart PLS?
Waiting for someone to bring that up. So you can do a formative factor analysis, but you would do it in a partial least squares environment like smart PLS. So quick rundown, what we're doing in EFA in SPSS is a covariance-based factor analysis. It takes a covariance matrix and finds groupings in it by rotating it and iterating through it. A partial least squares factor analysis does not do that. It does not use the covariance matrix. It uses the regression weights, which are different. So we can use partial least squares for formative factor analysis. Also, the criteria for validity and reliability are different in a formative factor analysis. Most people don't opt to go that route because there isn't as much support out there for it, but often formative models are richer. Not richer, more better. Okay. Going back to what we had here, our factor analysis. Okay. Use maximum likelihood in this case. And I'm going to do it based on eigenvalues. Continue. In rotation, I selected Promax. Rotated solution. I'm going to uncheck loadings plot because I'm expecting more than 3 dimensions. And so a loadings plot in 3 dimensions would be irrelevant because it's trying to fit 6 dimensions into a 3-dimensional plane. Continue. Let me mention something in scores now that we've gone through the EFA once. If you click on scores, you have the option to save the scores, the factor scores, as variables. What this does is it says you had 5 items on this factor and 7 items on this factor. Let me reduce that for you into 1 per factor. And it essentially creates a weighted average for that factor. So if I were to go back to, that's my error tone. So if I were to go back to here, I used to have that as my email tone. Students didn't find that respectful. So anyway, factor 1 and factor 2 would produce 2 variables total if I saved as factor scores. And factor 2, the variable that was saved, would create a weighted average of these loadings based on the weighting is these loadings. Instead of an even weighting, it's a weighting based on this loading scheme here. And then same with decision quality. So we'd have factor 1, which would represent decision quality with a single factor score. And information acquisition, which would be represented by a single factor score. That's what saving does. Yes, you're speaking. Hello.
So,
yeah. It would be thus. It's the centroidal, that's a word. The centroidal node. It is the most central to the trait we're capturing. So it is the one that receives the greatest weight. Yeah. She asked about the 0.997 remote folks. Yeah, it is the biggest influence. In fact, if we were to go look down here, this is a decision quality 8. If we were to look down here, it would be the rightmost dot. Decision quality 8. Here it is, rightmost dot with the strongest loading. Okay. That is factor scores. I'm not going to do that, but you can if you want. Options, I suppress small coefficients. And if I'm doing a completely unguided atheoretical factor analysis, which I've done in marketing studies, when you have a bunch of survey questions and you see what sticks together, I sort by size, because that tells me where the breakoffs are a lot better. So I'm not going to do that here because I know which items belong to which factors. Continue. Okay, and okay. And zoom out. Okay, so we fixed it. That means things will have changed. I'm going to go to the chat real quick. You just said formative constructs should be with PLS. Question. You mean do EFA with PLS? Yeah, you can do, well, it's not EFA at that point. It's actually a CFA because you're in PLS, you have to dictate which items belong to which factor. So it's a confirmatory factor analysis in PLS. Question 2, could we use Amos for formative? The answer is, in as much as you could use a car to go jet skiing, you could, but it's not designed for it, right? There are actually ways to manipulate Amos to take formative models, but it really isn't designed for that, and everything in Amos is built on the covariance matrix, so it wouldn't come out with the right outcomes. So no, please use a PLS software for formative models. Yeah. Yeah. You have the labels, right? So I know a lot of people are still facing this. So I'm going to review it. So the question was, I still have the variable labels here, and it's a disaster to read, right? I mean, it's just hard. So go to Edit, Options, and then on the General tab, make sure you're displaying names, not labels, and hit OK. It's going to reset some stuff probably. You'll have to recreate that factor analysis. Okay. Once you've done that, we come down, where were we? KMO, here it is. KMO is good still. Our extraction should still be good. Low of 367. Yeah, 367. Looks like to be our low, that's great. In the total variance explained cumulative column, we still have 6 factors. That's good. 63% variance explained, which is actually an improvement from last time. It was 61% last time. We scroll down to here, our factor matrix, and ignore it, just like the 4th child. And come down here. Ooh, what? Nothing. Look at the non-redundant residuals, model fit essentially. It's under 5%. That's great. Look at the pattern matrix, and hopefully it's all fixed. The 2 troublesome ones before were information acquisition and decision quality. You can see the information acquisition is fixed. It's roughly, it's actually probably just at 0.7 as an average. Good enough. Decision quality, 1. Dang it. We have a Haywood case here. Let's scroll down. Everything else looks pretty decent. So we have a Haywood case here. What do we do? There are multiple things we could do. Decision quality 8 is redundant, right? We can delete it. We're not losing any value. We delete it. Or we could delete our lowest loadings, 0.539, 0.568. What I would do at this point is I would do another Cronbach's alpha test, 6, 7, 8, 9, 10, 12. 6, 7, 8, 9, 10, 12. Another Cronbach's alpha, 6, 7, 8, 9, 10, 12. Get rid of 11, 13 and see what it looks like. 0.908. Can't improve it by deleting anything. So at this point, we could just delete 8. like I said, it is redundant. So why not just remove the problem? Hit OK and see what happens. Honestly, you could probably remove any of those items and it would fix the problem. Here it is. Uh-oh, cause problems. I love it when problems occur. Okay. By deleting 8, we deleted our strongest trait item. So let's go back and undelete it, and let's delete number 6, the one that's cross-loading. That's going to separate us further, which is what we want. So rerun, stick 8 back in, take 6 out. Yeah, because they're so redundant with each other. Yeah, so you could say I have Haywood case because they're redundant. But if they're redundant, why not delete one? Yeah. So this is where statistics gets to the whole wordsmithing of science. You pretty much can do whatever you want as long as it's rational and you can explain it. Doesn't work with cops though. I was going 70 because there was nobody on the street. Trees were going to take care of me anyway if I crashed. Yeah, didn't work. I got stopped in Mississippi on the way to seminary, and I was going, I was going 60 on a 35, and it was in the back roads. If you've been to Mississippi, it's all forest. And cops stopped me. I'm like, oh, sorry. You know how fast you're going? Yes, I was going 60. You know how fast it is? 35. All right, well, that's fine. Glad you know. We let the trees take care of the stupid ones. He didn't give me a ticket. He just said, you know, your life. Okay. So I went 60. Okay. Anyway. Oh, yeah, sped off. Yeah. All right. Wasn't always so lucky, but with the cops, I was lucky with the trees. All right. Let's jump down to the pattern matrix on this most recent one. I got rid of decision quality 6. And look what happened. Getting better. No Haywood case. Decision quality 8, reduced. Information acquisition, also reduced on number 5. We could delete that if we wanted. I think I'm going to wait on that one. Just see what happens in our CFA. Now, another thing we could have done is we could have just run this as a Verimax rotation. Check this out. I'm going to go throw decision quality 6 back in. So that should give us that Haywood case, right? Decision quality 6. So we should have a Haywood case if I run this again. Hit OK, jump down to the pattern matrix, and there's our Haywood case right there. If I do the exact same items, but switch it to Verimax rotation, what Verimax does is it pulls in the ends. The lowest loadings come up, the highest loadings come down, and it should be all hunky-dory. Amazing. Sorry, I just threw that in there to see what. Yeah, I'm just testing you. Okay, here we go. So we're going to go down to the pattern matrix. We just did Verimax rotation. Notice there is no such thing called a pattern matrix at this point. It's a rotated factor matrix. Same thing. Look what happened. What a mess. Okay, decision quality. It brought down decision quality 8, sure enough, down to 0.88. But it also made a mess of everything else. So I don't like Verimax. So subjective. That statistic didn't work for me. Let me try another. I'm going to go back to Promax. And I'm going to get rid of decision quality 6. And why not? You know what? Let's drop info acquisition 5. Just make it perfectly clean. It's redundant anyway. Hit OK. I know purist statisticians would be cringing at my language, but it works. Here's decision quality. Oh, look how beautiful this is. Information acquisition, clearly we're above 0.7 now as an average. Decision quality, we're above 0.7. No Haywood cases. We're good. We now have a clean EFA. We can move forward. Okay. let me just make sure. Yep, here's a chat. Drop it. Drop it. Yes. Okay. Drop happy. Here we go. There are a few things in an EFA. There are 4 things specifically in an EFA you want to make sure you cover. Let me go to the slides for these. Let me jump back up to here. I got to show you this because I spent time on it. Variables move together. It's hard to see which ones move together until you factor them. Then you can realize, oh, they are moving together, even if they're inverse. Okay. EFA, if you didn't catch it from a language, it takes the covariance matrix and rotates it, iterates through it, sees what sticks together, and then spits out a pattern matrix. It says, here are your groupings based on your covariance matrix. Boom. If you don't suppress small coefficients like we've done, then you get all the rest of these coefficients in here that are really small. That's why I suppress them. It's because it cleans it up a bit. If you don't suppress them, do be sure to highlight your factors so that they're easy to see. Someone brought up a cluster analysis. How is this different from a cluster analysis? EFA, a factor analysis, clusters variables. A cluster analysis clusters rows or people. So it's just a 90-degree rotation. Cluster analysis is cluster of rows. Factor analysis is cluster of columns. Applications is for a lot of stuff which we've talked about. We talked about this. It's reduction. Sort of talked about that. Number 1 rule of factor analysis. I should say rules. Or rule. It's useful for latent constructs that are reflective in an EFA. I should say exploratory factor analysis, because it's based on the covariance matrix. I get calls, emails all the time about bad factor analyses where they included things like marital status and age and gender and things like that in the factor analysis. Those don't make any sense to put in a factor analysis because they don't covary with things. Also, they're not latent. Okay, well, age covaries, but the others don't. Ooh, fancy. Hey, we're here. Formative versus reflective. Yes. Okay. So, before I get to this, answer these questions real quick. How do you know which rotation is correct? You fiddle. Actually, there are actually rules behind them. I have a slide for that. I'll get to that in one moment. I will get to that slide. Do you just go with the one that gives you a good solution? Yeah. No, maybe. We'll get to that slide. Principal axis, principal components. Which one is better? Again, oh, never mind. Okay, I'll get to the slide. Here we go. Formative versus reflective. So notice these are modeled differently. A reflective factor, the arrows, if you're modeling it, point away from the factor. Every item is essentially the same thing as the factor. It is reflective of the factor. Whereas in a formative measurement model, the factor itself is composed of or formed out of these items. And I have some examples here. And they're not expected to be interchangeable in this case because they are unique dimensions of this thing. Here's an example. Diet as reflective. You can have 3 survey questions. Strongly disagree to strongly agree. I eat healthy food. I do not eat much junk food. I have a balanced diet. Anybody who ate with me at lunch today knows this is all false. Strongly disagree to all of that. But all 3 of these move together. You would not expect someone to say, I have a balanced diet, and then say, I ate a ton of junk food. Right? They're not going to say strongly disagree to one of them, but then strongly agree to another one. They're consistent with each other. And it would be irrational and inconsistent to say, I have a balanced diet, but I don't eat much healthy food. That's irrational. So they should move together. Whereas a construct called health, which I'm measuring formatively right here, you could have, I have a balanced diet, I exercise regularly, I get sufficient sleep each night. These 3 things form the idea of health, right? This is a healthy set of behaviors. But I can have a balanced diet and never exercise. I can exercise and rarely sleep, right? I can sleep great, but eat terrible. They don't move together, although they might. They just don't have to. They're not interchangeable. They're not compelled to be or assumed to be correlated. But with their powers combined, you have this thing called health. Yeah? The reason formative doesn't work in an EFA and doesn't work in Amos, again, is because those two things are built off the assumption that the underlying items covary. But formative has no assumption of covariance. Therefore, you cannot use formative items reliably in an EFA or an Amos. Okay. That is one of the most complex concepts in SEM. So if it didn't make sense, yes? Yes. Yes. So the behaviors that lead to stress and stress trait itself, I would say, are two separate factors. Yeah. And so you'd measure them separately. Yeah. Although you could formatively measure stress via its symptoms. Yeah. Yeah. But that would be formative. Sorry, go ahead. No, they don't. It's horrible. They're all formative. All formative. Yeah, for remote folks, she asked, do people actually follow this rule? The answer is no. There was an awesome study done by someone at some point. I can't remember the study. I think it's Mackenzie or I don't know. He did a lot of stuff. But he looked at all of the marketing research in the top marketing journals. There's over 100 studies he looked at. And he looked to see if they use formative or reflective measures. And of the ones, I'm gonna get this all wrong, 80% of statistics are made up on the spot, but they're based in reality. But something like 80% of the models that were tested reflectively, even though like 50% were formative. And so what happens when you test a formative set of measures reflectively is you realize, hey, they don't load together. There's a really low loading here, and this loading's way over there. So what do? You drop them, right? You delete that item, you delete this item, and then what you're doing is you're destroying the formative construct. Because imagine here, if we took away one of these items on health, what happens? It's no longer the same thing. It's not diet and exercise and sleep. It's diet and sleep. It has nothing to do with exercise. And so we now say health has nothing to do with exercise, which is wrong, right? Whereas if in reflective scales, if I were to delete one of these, it wouldn't really make a big difference, right? Like, well, you eat healthy food and you have a balanced diet. Those are sort of the same thing. So I assume you don't eat junk food. I don't even have to ask that, right? Here's a good exercise for this. And I'm going to answer these questions real quick. Can you give reason for dropping that 8 factor, please, if we had one? Or the whole factor. So if you had an 8th factor and you were only expecting 7 factors, for example, I would drop it because it's redundant, I assume, with another factor. If it was part of the other factor to begin with, and it just split off 2 items, I would say it's redundant. Excellent. What happens to my model? What happens is my model has both formative and reflective. Oh, yeah. Okay, if you have formative and reflective constructs, you have multiple options. One option is to just go the whole covariance-based route, use SPSS and Amos, and for all of your formative factors, create indices or scores, which are essentially weighted averages that you design and develop and calculate yourself. So let's say you have 5 items, you say this one's the most important one, this one's not so important, you weight them differently, create some sort of score for your formative factor. Now that decreases the richness of the factor because it doesn't account for measurement error in a latent structure. But most people don't catch that. The other option is if you have a formative and reflective model, just do it in PLS because that can handle both. So PLS can handle reflective measures, but it can also handle formative, whereas Amos can only handle reflective. So the question is, why don't I just always use PLS? because it actually has a lot of other limitations. It doesn't provide model fit statistics. It inflates a lot of your coefficients. It gives a lot of false positives. Let's take a 5-minute break real quick, and we'll come back to this. Okay, so also go to output. And changes to names. And the next one changes to values.
You got immediate or I got rerun?
You probably you might need to set below that as well. Hey, look at that. And then so let's go back to your options. So in the output tab, which is bring our names for it. I use values labels. It's on the output tab. And then we create it. Yeah, that should do it. Welcome.
The biggest reason people don't use LS because their organizations.
Okay.
Exactly.
Where is it?
Not anymore. Unless people use it.
It's only free, not too long.
Yeah, version 2 was.
Yeah, and then so what they do instead is they go in and find rockets or argue basically.
If you have something, once you establish that, I guess you can do that. I think that's one else to make sure. Sure, that you want to take that. So that's the real right. Go back. Because I'm guessing there's a conceptual difference between those last two and those first three. Yeah, it takes the one that matches the trait you really want to capture. Yeah, so which one is they're probably capturing two different dimensions. Or you could just decide. The first or the vice versa. these orders would be.
Tell her about the residencies. It's intense, yeah. Yep. But it's like a boot camp every 3 weeks. Yeah. Let's see, there were questions. Let's see. Since we're on break, just wanted to clarify that if you delete an item and it improves Chromex Alpha, the way you see this improvement is when Chromex Alpha goes up, actually, goes up. Conceptually. Yeah, you read the items and you say, oh, these 3 are about this thing. But these 2 are about something I wasn't even intending. Or maybe these 2 are about the thing I want, but these 3 are not. Yep. Yeah. Pick one and run with it. All right, let's see. Is it good? Is it okay to have a loading at 0.490? Yeah, that's fine if the loading is in the mix with a bunch of higher ones, so that the average loading comes out above 0.7 roughly. Let's see, sorry, but some wave when listening your voice. If my model has formative and reflective, I understand one option is PLS with its limitation. What is the other option? The other option is Amos or Lizral, or there are several actually. You could use Stata, M+. There are a bunch of different SEM modeling softwares. You see the improvement to the Chromex Alpha because it goes up. Yes. Okay, thank you, Chromex Alpha, page 35. Thanks. Okay, cool. That's all of them. All right, we have almost everybody back. We'll wait a second.
I have one question from before, James. Can I ask you?
Yes.
When you're doing the t-test, if I have one factor and I have calculated that over 1 to 7 scale, but I want to do a t-test saying that what is the difference between means for another factor based on people who are low or high on this variable, so a split from one variable and test other means. Would t-test do this? Am I clear?
You want to determine if a particular variable, let's say satisfaction, easy to think about. So you want to know if satisfaction differs based on the high or low value of a different variable?
Yeah.
Yeah, t-test would be perfect for that.
And ANOVA, when would we use ANOVA?
ANOVA is when you have more than 2 groups in your grouping variable. So at a high-low, it's only 2, right? High and low. But let's say you have high, medium, low. Well, then you'd need ANOVA because a t-test could only compare 2 of those groups at a time.
I see. Thank you.
You're welcome. All right, everybody's back. Let's go to this. Looking again at formative versus reflective. I want you to look at these items. It is, thank you for, yes, it is recording. Thank you. Tell me, do you think this is formative or reflective, this set of items?
Reflective.
Yeah, reflective. If you remove one, it doesn't really change things, right? They all say the same thing. I'm not going to answer strongly disagree to I love my job and then say strongly agree to I'm very satisfied with my job. They're going to move in the same direction. How about this one?
Formative?
I've heard a lot of mixed answers. What do you think? Take a stand. Formative. Here's why. here's what I say it's formative. I could say that a software is useful. Like SPSS, right? Amos, we haven't used it yet, but it's useful. But it's not easy to use, right? You can answer those totally differently and still be a rational human being. I'm satisfied. Yeah, maybe. I could say no to one or yes to another, but still have it not be easy to use or useful. Helps me get work done. I can be, again, they don't move together. What about this one? This one's tricky. Yeah. There are multiple reflective dimensions. So it's both formative and reflective. It's reflective at the lower level. So you can see 1 and 2 are reflective with each other, right? I work well with my colleagues and I get along. Same thing. But that's different from my boss is fair. But my boss is fair is the same as my boss doesn't discriminate. That's like the definition of fair. And 5 and 6 also move together, but inversely. So at a low level, they're reflective. 1 and 2 are reflective of each other. 3 and 4, and 5 and 6. But at a higher level, those 3 groupings don't reflect each other. They are formative. So you'd actually create a higher order construct in this case, composed of 3 reflective dimensions.
On 1, 2, 4, and still not
Reflective.
Right. So, but the question for remote folks is, how well would satisfaction work in a formative scale?
as a rule of thumb.
So, as a rule of thumb, one way to address formative factors is by looking at their manifestations. So often that's how we compose formative scales, is through their symptoms. So we wouldn't ask someone in a formative scale, how satisfied are you? We'd say, do you enjoy your job? Do you have a lot of stress at work? Do you like your colleagues? These are all signs of satisfaction. And that would be a formative scale of satisfaction. Okay, somebody said this is reflective. The orange one. Anyone disagree? You are wise to not answer. It is reflective. Even though number 5 is reversed. I feel micromanaged is still the same thing as saying I feel empowered. It's just saying it in the opposite direction. Okay, chat, let's see. Yeah, it is reflective. Good. Like was mentioned, people get this wrong constantly. I had to reject a paper recently. I'm an associate editor at Frontiers in psychology. And I got assigned a paper on tourism for some crazy reason. And I rejected it because their entire theory was built on the assumption of formative measures. And everything they measured was formative. Did I say formative? Sorry. It was built on the assumption of reflective measures. Everything they did was formative. And here's why. So here's one of the questions. I've adapted it, so I'm not stealing somebody's stuff. But it is essentially this. Indicate the importance of following sources of online information when it comes to familiarizing yourself with Salt Lake City. Not at all useful, and one of my main sources I've used. And they had a list of various things you could have used as you were thinking about touring around Salt Lake City. And people would check them. So it's a binary scale. 0 or 1. If it's checked, it's 1. If it's not checked, it's 0. And they use this in an EFA. Lo and behold, 2/3 of them dropped, right? Because they weren't loading together. I wonder why. And it's because I can totally use tourism blogs and not use social networks and still be a rational human being, consistent in my behavior. But they argued it was, anyway, formative. That's formative. If you wanted to use this, what do I want to say about that? If I wanted to use it in a model, I couldn't use a factor score or a latent factor of these. It wouldn't make any sense at all, these binary checkboxes. What I'd have to do is change the construct from online sources, which doesn't make any sense, and that was their construct name, to the extent to which I leverage online sources. And then I'd have to create some sort of index that summed up the number I checked. And then that's the extent to which I use online sources. And then I can use it as a variable in my model. I can't use it latently. Okay. So if you have formative measures, we talked about this, use SmartPLS. Currently, SmartPLS 3 is the leader. There are other PLS softwares, Warp PLS, PLS GUI, XLStat, PLS Graph, which is no longer supported. SmartPLS 2 is free, but has some known errors, not big ones though. SmartPLS 3 is expensive, so you probably won't get support for that from your institution. Anyway, those are the PLS softwares.
But you could use PLS reflective measures as well, though, right?
Yes, you can. You can use PLS for reflective measures, but again, it inflates coefficients and results in a lot of false negatives. No, sorry, false positives, where you think you have a significant relationship, but you don't actually. Also, it doesn't have model fit measures, which means that it's hard to tell if you've specified your model correctly. Whereas in something like AMOS, the model will tell you if it's a bad model. In PLS, it doesn't do that. Although there are efforts to make it happen with the AIC and BIC. Sorry, that was too much info. This is just FYI stuff. Hey, here's that study I talked about. Miserable, mediocre, middling, meritorious, and marvelous. Yeah. 1974. You get away with all sorts of stuff back in 74. I would know because I wasn't there. Okay, we talked about these are just everything we've already gone through with explanations of what they are. Here's that slide I said I promised I'd get to, which extraction method, with explanations of what each does. And I'm not going to go through all of that, but it's there for you to look through. And rotation methods, all the info. We talked about that. Talked about that. Talked about that. Talked about this. I do want to say one more thing on this. Let's do this really quick. Watch this. Escape. That's escape. Sorry. I have to use real words. Here we go. Factor analysis. I'm going to do a factor analysis real quick. Just watch. Don't follow along. Just watch. I'm going to get rid of everything here and just stick decision quality is a big one. Let me stick decision quality in here. And I'm going to force it to 2 really quick. So just watch though. Don't try to follow along. Okay, I forced it to 2. And here's the pattern matrix. Let me zoom in. Okay, so I have a factor. It splits itself off into multiple factors. What do? Luckily, I have a lot of items for it, so I have a lot of flexibility. First thing I would do is I try to reconcile. But what I do here is I look at the highest loadings, 7 and 8, 8 and 7, or 7 and 8, 11 and 12. I'm going to go look at 7, 8, 11, and 12 and see how they differ. Go look at the wording of the items, 7, 8, 11, and 12. Here we go. Decision quality, 7 and 8, and 11 and 12. Excel helps me make more efficient or effective decisions. Excel helps me make higher quality decisions. Okay, so that's about effectiveness and quality of decisions. Excel helps me make decisions more quickly than it would otherwise take me. Excel helps me make decisions which I can be confident. I don't see a pattern there, actually. But if these did represent multiple dimensions, I could just say, well, this is the dimension I want. I want 7 and 8. I don't want 11 and 12. I want 7 and 8. And that's what I do. I would lop off the one I didn't want and say, this is the one I'm going with. Theory, that would be based on theory. This is the construct I was intending to capture. These other items accidentally captured something else based on their wording, and I see it now because hindsight is 20/20. But I sure didn't see it going into it. Yeah, based on the wording of the items. This happens all the time. You think you have a reflective set of measures, and you accidentally capture multiple dimensions. Happens all the time. It actually happened with this data set. I captured a construct called system satisfaction with 10 items, and it turned out to be 2 different factors, totally separate. Those 2 factors, information acquisition and decision quality. In fact, you may notice, it was 13 items. You may notice these are numbered 1, 2, 3, 4, 5, and then decision quality starts 6, 7, 8, 9, 10. These used to be all labeled system satisfaction or system success or something like that. And I realized after I collected the data, after I did the EFA, there were 2 separate things, and I renamed them after, changed my theory as well. Yep. But that's also why we see them highly correlated, because they used to be the same thing. Please, PowerPoint page 19, create aggregate scores. Is this with Amos, Lizrel? Please explain a little more how to do this. Page 19 of the PowerPoint. Let me go there. Page 19. Oh, this? It's with PLS. Did you mean page 19? This is with PLS. No response. Oh well. Okay, hopefully it's with PLS. Okay. Here we go. The thing you want to keep in mind as you're going through and doing your EFA, you want every item to have a home. And you don't want it to have multiple homes. You want every item to load strongly on one factor and weakly everywhere else. What is the closest it can be? There's a paper out there. It's Geffen and Straub, 2008, I want to say. Geffen and Straub, might be earlier than that. I think it's in the CAIS journal. That says you can have loadings within 0.1 difference. So like this BM5, we could have a loading of 0.8 right here, and we'd still be fine because there's a loading of 0.9 on its primary factor. I prefer a 0.2 difference. It's a little more conservative. Geffen and Straub is probably in there. Let me check. Geffen and Straub. It is not, but if you are looking for references, and you would go to StatWiki references. References is right here on StatWiki. And I have all of them here. Control F, Geffen. There he is. Geffen and Straub, 2005. Okay. Practical Guide to Factorial Validity using PLS Graph. Same principles apply to Smart PLS. Okay. I sat next to David Geffen the whole way back from China. We didn't talk though. He watched movies the whole time. I told him I was the YouTube guy, but this was back 3 years ago, so I didn't even have 1 million views yet, so he had no clue who I was. Probably still has no clue who I am. Okay. Oh, somebody found it for us. There it is. Oh, this is 2000, that one. Cool. This one, yeah, it might be in this one, but it is definitely in the PLS one here on references. Okay. But again, you want to have every item have a home factor. You don't want two groupings of items on the same factor. Then you have a discriminant validity problem. So like if I had another set of high loadings here, that's a discriminant validity problem. You also want to make sure that the factors load where they should load, or the items load where they should load. You don't want an item loading on a separate factor that you never thought it would load on. If it does, that's a problem. Loading, yeah, we have a reference for this. Sweet. Haradol, 2010, table 3-2. This is the required loading size based on sample size. So we have a sample size over 350. So we can have loadings as low as 0.3, and they're still meaningful. Yeah, but that's what I said too. AVE doesn't care what our sample size is. AVE is a measure later that determines if we have convergent validity. Excellent. Adequacy, do the variables move together or sufficiently covary? We talked about that quite a bit. Validity, there's convergent and discriminant validity. Convergent is, are the loadings high, roughly above 0.7? Discriminant is, are there cross loadings? You can see here there are cross loadings with loyalty 8. Convergent validity, yeah, they move together. Yeah. And evidence of movement together is high loadings. And, oh, we didn't talk about this, factor correlations. If I go over to here and go look at a pattern or an EFA that we just did, and I can look at the very bottom of any EFA and it'll give me the factor correlation matrix. You want to make sure on this factor correlation matrix that there are no correlations greater than 0.7. Why? It's because if you were to square that correlation, you get the percent of shared variance, and you don't want it more than 50%. 0.7 squared is 0.49, which is almost 50%. So here's factor 4 and factor 5. They have quite a bit of shared variance. If you were to square that, you get 37%, which is fine. It's less than 0.7 there. I bet that's information acquisition, decision quality, 4 and 5. Let's go see. Right here, 4 and 5. Number 4 is decision quality. Number 5 is information acquisition. Yep. So they have high correlation, but not so high that we're worried about it. There's still discriminant validity. Okay. Yeah, no two factors should have higher than 0.7 correlation. If they do, then you got to wonder, are they actually just the same factor or different dimensions of the same factor? In that case, in fact, if we haven't talked about this, but if you have a second order factor, a higher order factor, like, where'd it go? Here, like, over here. Remember this red one here? This red one had multiple dimensions that were reflective, but that at a second order it was formative. We could throw this into an EFA, and we expect 3 dimensions to come out. Right, 3 factors, 1 and 2, 3 and 4, and 5 and 6. They should come out as separate factors. Because they are part of the same second order factor, it's reasonable for them to have a correlation above 0.7 because they are part of the same factor. This is the only exception to that correlation rule. Yeah, it confirms discriminant validity, because you don't want them to have too high of a correlation, or else you wonder, are they the same thing? Discriminant validity is about, are they different? Distance between factors, groupings, whereas convergent validity is about tightness within groupings. They would, yeah, highly correlated factors, you'd observe cross-loadings. So they should be evident, and if we reduce our suppression from 0.3 to 0.2, I bet we'd see some of those. Okay. We talked about all that. Validity, adequacy, we got to there. Here we go. Here we got to that one. Reliability, we talked about. Your convex alpha greater than 0.7, we talked about that. Whoa, we got through all of it. I want to do a messy EFA. We have tons of time. This is good. It's really good. Okay. There are also exercises and optional things. we have two options for a messy EFA. I can take one of you guys' data. Nobody in the DM program. I can take somebody else's data. It's not involved in the capstone. And having never seen it before, nothing up my sleeves, I can try to do an EFA on your data. I actually did this one year. The student had been wrestling with the EFA for months. And he said, if you can figure this out, I can graduate. So no pressure. We figured it out. And he didn't even give me fudge or chocolate or anything. So it's really disappointing. Huh? You did graduate. Yeah. So he's welcome. Let's see. What do you do with loyalty 8? Loyalty 8. Oh, back here. So over here, see loyalty 8 is cross-loaded. Notice it doesn't even have a home. There's no loading there greater than 0.5 on loyalty 8. What do? I would just drop it. There are 8 items on loyalty. Just drop it. If we have time, can we do can you use system satisfaction? No. Nice try, Rich. It's part of the capstone. If we have some time, can we do a second order factor? I would love to. Yeah, that'd be great. Yeah.
That was awesome.
First order being reflective, second order being informative. If we have time, doing messy EFA. That'd be great. So I'm getting some data. Does anyone else have, okay, let's see. Isaac's sending me data. Mark is sending me data. You have messy data on Charlie Brown? You never know. As a professor, I occasionally run into these issues. Let's see. Oh, Charlie Brown's head is too fat. I can go on the other side. Here we go. This way. Okay. Continue without scanning. All right. Where could I find it? You just want to help me out. $15? This one? Sorry? Okay. This isn't part of an exam, right? I've been asked online, okay. I've been asked online questions that look suspiciously like final exam questions. I'm like, does your professor know you're asking me this? Go ahead. All right, which one? Either one? Oh, is one of them messier? Teen, yeah, I could have guessed that. Teen's messy. Yeah, I'm gonna go put it in my stats service. Now, okay, I've got some messy data. What just happened? Uh-oh. I just hit enter. We're gonna work with that later. Okay. I think I didn't. I must have missed. Okay. Teen data. Stat service. Replace, sure. This is my folder. It should be at the top. I'll just type teen here. Here it is. Okay. Okay. Excellent. Okay. We have some data I've never seen before. I don't know you, you don't know me. We didn't collaborate before this. Yeah. Yeah. There we go. So the first thing, I actually get data sets like this all the time. If I were to show you this folder, in fact, I'll just show you this folder. I clean it out regularly. Let me do this, .sab. Here are all the data sets people send me. And I clean this out monthly, probably, almost monthly. And they send me data I've never seen before and say, what's the problem? I'm like, I don't know. And so I look at the labels. If they have labels, that's trick 2. And before I even look at these, because typically they give them to me like this, where they're all named something completely non-semantic, something just systematic, like Q1, Q2, Q3. Totally useless, right? So that's word of advice for you guys. Make sure you label your items something sensible. Okay, tell parent, P is parent, okay. Tell parent where I really go. Tell parent who you'll be with. Tell parent everything you plan to do. Tell parent when you'll be home. These are neither formative or reflective, right? It could be either. Call text when plans change. Tell parent everywhere you went. Tell parent everyone who you was with. Oh, who was with you? Sorry. I lived in Mississippi for a while. You gotta forgive me.
That wasn't me.
Okay. All right. I just got back from Pennsylvania. Anyway, okay. The podunk part of Pennsylvania. Tell parent who you were with. Tell parent everything you did when you went out. How often keep we're going a secret from parent, so that's reversed. How often keep other people's secret from parent? That's reversed. How often keep plans secret from parents? Reversed. Okay, we're going to throw all of these into a factor analysis. My guess is we're going to have multiple dimensions that I'm not seeing yet. So let's find them. Let's throw these in. Looks like you came out with 2 dimensions. Let's find out what I come out with. I'm going to use maximum likelihood just as a starting point. I might have to change that. We'll see. Rotation, again, just starting point, Promax. Yeah, you know, that's a good idea since we have probably just 2 to 3 dimensions. Let's do a loading spot. Scores, I'm going to skip options. I am going to sort by size because I have no clue how they're supposed to factor. So I'm just going to sort them, make my life easier. And I'm going to suppress, but only at 0.2 because I don't know how clean this data is. Here we go. I should ask first. This is just, what is your sample? Is it just teenagers? Okay, see if they mesh. I'm sure they're very different, yeah. With these teens, are they all part of the same population? Okay. Tell me a little bit about the population. Okay, high school students. Okay, okay, cool. All right. There are no major demographic differences. I guess that's what I'm getting at. Is this like male, female, rich, poor, race differences? It's just potluck. Okay, that's what I want to know. If randomness is going to take care of all the differences. Okay, we have a sufficient sample size that randomness is going to be able to clear up some things, any grouping differences. Let me, there we go. So 0.839, looking pretty good. That's meritorious, I believe. Extractions, looks good. 0.317, not bad. Great explained variance. And look at the gap. This is what I like to see. I like to see big ones over 1 and then a drop way below 1. That's a good sign. That means we got the right number of factors there. Skip the factor matrix. We produced 29%. So what's that telling me? That's telling me 2 factors actually isn't a great way to explain this data. Maybe there's another way to explain it better. Here we go. Wow, those are high loadings. Ooh. And it's split maybe as expected. 9, 10, and 11 were about concealment, right? They were reversed. Let me check it here. 9, 10, and 11. I keep secrets, concealment. So yeah, they're different. But I want to try 3 factors. I just want to see, in fact, I'm going to take out all of the concealment for just a sec, just so I can see if there are any dimensions on that 1. There aren't. It came out as 1. Let me force it. Extraction. I'm going to force it out to 2. Maybe it's 3. Who knows? You know, I want to see a scree plot. Where did the scree plot go? I want to see if there are elbows. Okay. You see the difference between 3 factors and 2 factors? Nothing. 4 and 3, nothing. 4 and 5, definitely nothing. 5 and 6, quite a big jump. You might say there's either 1 factor, 2 factors, or 5. Let's see if we have 2 here. Hey, they did split out nicely. Kind of nicely. Yeah, these low loadings here. I'm going to try one more time, 3 factors, just to play. Even though the eigenvalues don't support that move. But look, I'm explaining 71% of the variance right now. That's really good. Also because I only have a few items. Look at this. 0% non-redundant residuals. That means I am explaining the model very well. I'm explaining the data very well. That's awesome. Let's look at the pattern matrix. A lot of weird stuff going on. And yet it's better in some respects, right? But what it's saying is there are really 3 things here, possibly. Numbers 6, 7, and 8, 1 and 2, and then 3, 4, 5. Could be asking separate types of things. But honestly, if I'm just going with the statistics, I'd go with 2 factors. Really? How about that? Let's go look at it. 1 and 2, 3, 4, and 5, 6, 7, and 8. So 1 and 2, where were you? Who you be with? 3, 4, and 5. What are you going to do? When are you going to be home? What are you going to do? Plans. 6, 7, and 8. Where did you go? Who was with you? And what did you do? See, that's all 3 of them. I'm really surprised this didn't factor differently. I would have said there are wheres, like where are you going? There's who are you with? And there's what are you doing? I would have thought it would have factored that way. But it didn't. Probably because teenagers were answering it, and they just put somewhat agree all the way down. Okay. All right. So that was a failure. Sorry, that wasn't much of a success there. Let me just make sure the chat's. I'm going to do one other set of data. My data is collected over 2 waves, so too much. Just handpick a few factors you prefer. If I understand correctly, second order can only be formative. Am I right? Second order can actually be reflective, which sounds crazy. But you can have reflective dimensions. I don't have a great example of that right now, but you can have reflective distinct dimensions that are somewhat interchangeable. Oh, sweet. All right, Mark has one like that. You can have a second order reflective construct. So it's reflective at the second order and at the first order. So those first order dimensions are actually interchangeable to some extent. They're highly correlated is really what we should say, not interchangeable. So I have Mark's and I have someone else's. Let me use the other one first. Here it is right here. And let me close what we have here. Close all windows. No, don't save. And abstain data. Okay, I've never seen this data before. We'll see what happens. That's a lot of data. Holy shnikes, 2 megabytes of data. That's my Mormon form of swearing. Holy shnikes. I want to see you translate that. Yeah, shnikes.
Just a quick point. You might have to change the type of data to numeric, or I just sent you another one again. You can just get it.
I just use the new one? Okay. Oh, it thinks they're all nominal? Okay, there's actually a way to fix that. But I'll show you. So if I change them to ordinal, starting with perceivedus, right here. If I change this to ordinal, if I could use my shortcut keys, copy and paste, which it won't let me right now. Maybe I can go to edit, copy, there we go. And I select all of this. I should be able to just paste right over it. That is a lot of variables, holy cow. I'm just gonna assume these are all ordinal for now. And I can go edit, paste, and it doesn't work. Works sometimes when I'm alone. So let me close this one. I'll use the one you just sent, the new one. All right, you just sent the new one, you said? Large, so it's probably still sending. Thinking. While it's thinking, I'm gonna grab marks here. Yep, I got it. Okay, privacy concern. Yeah, that's a multi-dimensional higher order construct, right? Third order. Holy cow. Okay. Third order. Oh, privacy concern? Yeah. We have lots of scholars or people in our department who use privacy security constructs. Okay, all the PC? Let's do it. Okay. It's complicated. All right, so we're doing privacy concern. I am not familiar with this area of research, but they are labeled such that I'll be able to tell if they're falling in the right place.
Oh, you're using that.
So, so what you might do if you didn't know what you were doing is you'd include all your reflective latent factors. So I'd include all the RTB stuff as well. All right, to be forgotten. Or was that part of it? Okay, so, but if I were just running this somewhat blind, I might throw them all in there and realize that when I do that, they collapse on each other. You'll have a lot of discriminant validity issues because you have a second order or third order construct. And so, of course, they're related. So, of course, they have cross-loadings, and some of them are going to collapse. And so what you'd have to do is find out where the second order constructs, where all the highest order constructs were, and then do them separately. You want to run separate EFAs for higher order constructs. Otherwise, you'll have this collapsing issue. So I'm only going to run PC in here. Then we'll run RTF or BF if we need to. Also, you said it's reflective underneath? Okay, so then we can keep it how we had it. Beautiful. Whoa. Beautiful KMO, Bartlett's. Extractions are all just marvelous. It only came out with 2 factors? All right. Roll up my sleeves for this one. Here we go. Okay. 2 factors. We expected how many?
7 first order, 2 second order.
Okay. What I might do is break out all the second order. Okay, let me just look at it first after I'm done rolling up these sleeves. Here we go. Okay. Let's find out what's going on down in here. Oh, look at this. Look at these eigenvalues. 12 and then 1.96. That's so close to 1. You have at least 3 here. You say you had 3 second order? 2 second order. All right. I bet that's what we found here. Let's go down here. The reproduce is probably going to be hideous. Yeah, 28%. Pattern matrix. Ugh. Oh. That's awful. Yeah, that helps a bit. Oh, wow. Okay, let's play with that. Okay, so what we're going to do, that helps a lot. Okay, what we're going to do is we're going to break these out into their second order factors because this is a third order factor right here. So we're only going to do it for a second order at a time. So we need DEL, which is not listed here. Oh, sorry. Oh, it's the one below. Okay. Yep. All right. So I'm going to look at interaction management to start with. Okay, interaction management is COL, SEC, and CON. Get rid of these. All right. Yep. All right. We should theoretically get 3 factors out of this. Let's see if we do. And the answer is no, we get 1. Let's just change one thing. In extraction, I'm going to change principal axis factoring. Continue. Hit OK. Still comes out with 1. Fine. Let's force it. Let's force it. And this happens all the time with second order factors because they are interchangeable to some extent, those lower orders. Okay, we force it to 3. Let's see what and here are the loadings. Here's the pattern matrix. Is this what we expected? This is exactly what we expected. And look, they're beautiful. And so what do you report? You just ran it 5 times, and 4 of those times, it was disgusting. And you were letting it be organic, as an organic EFA, letting it just fall in place as it should. And it fell in a heap. So can you then artificially constrain this model to 3 and say, this is our EFA, it's beautiful, tremendous, beautiful, right? Yeah, you can. But you say, because this is a second order reflective construct, we expect the underlying factors to be correlated. In fact, if we go down to the correlation matrix here, look at this, 0.79, 0.7, 0.752. We expect them to be correlated because it's a reflective second order construct. Now let's go do this with the other ones and we'll observe the same thing.
First order ones and then use those in second order.
So you can. So the question is, do we now try to work an EFA to the third order? We can. We totally can. Or you can stop there in the EFA, put it aside, do another second order factor, put it aside, and then bring it all together like you have here in this picture, this third order reflective latent model. You can do it in a CFA at that point, and then you don't use any factor scores. You'll probably end up with better results that way. Move. Oh, but now you can go back and show, hey, look, even at the EFA level, it works. You just have to constrain it. Let's do this on one other dimension real quick. Let's see, information management is just 2? Yeah. Okay, so we should end up with 2. You can also show their convex alphas. I assume you did that for each of those, and they should be fine. So we need ERR and ACC. ACC, ERR, and extraction. By the way, why did I move this to principal axis factoring? Principal axis factoring assumes the factors are related and then ignores that relationship so it can separate them. It doesn't take into account overlapping shared variance. That is what. Actually, I'm going to go by eigenvalues first. Continue. Okay. Came out with 1, not what I wanted. So let's throw it to 2. Not there, here. Continue. And okay, please work. Here's 2. And we go down. 0%. And beautiful. Absolutely beautiful. And we look at the correlation matrix, sure enough, 0.748 as expected, because it's a higher order reflective construct. That's great. Nice. I'm going to do real quick. You can take it. I'm going to do a convex alpha on one of these, just to make sure we're clean and clear. So I'll do an ACC. ACC 0.854. Looks great. Okay, that was fun for me. You're good. Yeah, well, actually, we have a lot of BYU professors who advise DM students. Okay, there was a question here, chat. It can work on either way. What does it mean, sort by size? Oh, sort by size is when you really have no theory as to, no measurement theory as to which items belong to which factors. And so you're just going to sort them. I'll just show you. Let me just show you. Check it out. If I run this factor analysis and options sort by size, what it's going to do is it's going to take the strongest factor and put it in the top left. And the next strongest factor, put it in the next column. And it's going to list those factors in order of strength. So if I zoom in here, you can see ACC is a strong factor, and the highest loading appeared first, 0.802, then 8.6, and then 7.5. Again, in order descending, in order of amplitude. So that's what sort by size means. Makes it really clean. It always goes left to right when you do that, top to bottom. Yeah, but also it reorders them. So it used to be 1, 2, 3, 1, 2, 3. Now it's 1, 2, 3, 3, 1, 2. So it reorders them. Doesn't matter that much. It makes it prettier, easier to read. Okay. There was one more data set, but I had data where scree plot indicated clearly a major difference between first and second factor. Just FYI, that is always the case. There will always be a huge difference between the first and second factor, except in weird circumstances. Then I run parallel analysis, and results suggest to retain 4 factors. 2 questions. What is your opinion on parallel analysis? No idea, don't know what that is. And what would you do in such case? Easy answer for that, don't know. What is parallel analysis? Anybody know what parallel analysis is? Excellent, I'm off the hook. I have no idea. That is the next aeration hole over on my golf course. I've never heard of parallel analysis. What's real tricky is when people email me and they think I know everything about statistics. And it feels horrible because it reveals how little I actually know. They'll use all these acronyms and abbreviations for all these things I've never even heard of. And I'll be like, sorry, I don't know what you're talking about. What is a p-value? And then they'll laugh and decide to ask somebody who actually knows what they're talking about. Comparison between randomly generated eigenvalues and actual eigenvalues. Really? I didn't know that was possible. Cool. Huh. I don't know. Sorry, Emmanuel. I've never done that nor seen it. I should learn that. Oh, you can do it in Stata maybe? Stata? I'm going to say Stata. Okay. Here's the last one. Voila. Or Viola. Thank you, Isaac. And I'm going to copy and replace. Okay, this is the last one we're going to do of a messy EFA. And then, if there's time left, we have a couple other things I could show you, or I could just answer questions, or work one-on-one with you. Okay, abstain data. While that's coming up, let's see, parallel significant principal components. Cool. All right, so here's the data. And you said you have a bunch of variables here. You just want me to throw a bunch in? Or are there certain ones you definitely want? This is from Isaac. Isaac, are there certain variables you definitely want me to throw in there?
Yeah, you can go with addiction, craving, urge.
Addiction. Urge.
Yeah.
You said craving?
Yeah. And then maybe satisfaction. There should be that craving.
Status absence. This status one?
Yeah. Yeah.
Including that first one?
Yes.
You said there was something about cravings.
Yeah. It's somewhere there.
Crave. Oh, here's another satisfaction. Is this the one you really want?
Yeah, you can use that. I mean, they're interchangeable. Right?
I don't see crave. Crave's definitely in here?
Self-efficacy, if you see that one, or efficacy, one of
Yeah,
those.
you can use self-efficacy.
Yeah. That should give you enough messiness.
I found it.
Okay.
There we go, craving. Okay, let's try this and see what happens. Have you had trouble with this one?
Yes, a lot.
Good, that's what I want to hear. I like it when you suffer. That means you learn or get resentful. Something. Let's see, 0.3. Okay, we expect addiction, urge, satisfaction, craving. We expect 4 factors to come out of this. And we get a good KMO, 858. Extraction, I can see we're going to have, they're not too bad. Ooh, instead of 4, we got 6. Excellent. 9% non-redundant residuals. Here's the pattern matrix right here. Very poor loadings. Oof. My question is addiction formative or reflective? Let's go find out. Urge, not too bad. Satisfaction, great. Craving, great. So really, it's addiction, and maybe urge. Let's do 2 things. First, let's start with addiction. I want to go look at the items for addiction. Here they are, right here. Woo. And right here. Okay. Sorry, I can't zoom. Well, I could zoom in because they're all on the right. It's based on experience with social networking site. Please indicate the extent to which you agree with the following statements. That prefaces everything, and then I'm going to zoom in. Okay. I need more space. Oh, dang it. Control Z. Okay, here they are, right here. Much of my time is occupied by thoughts about using the site. My thoughts about using the social network site interfere with my social, school, work, and other functions. My thoughts about using this social network site cause me anxiety or distress. I often try to turn my attention away from the thoughts of using this site. I have much control over my thoughts, so that's reversed. I spend much of my time using the site. My use of using this social networking site interferes with my social. I become anxious. I often resist. That's reversed also. I have much control. Also reversed. So you have several reverse coded questions. Have you, Isaac, re-reversed these yet?
I did, but it's, I have to look for it. It's another file. Why don't you just remove those 3 items?
Okay, yeah, sure. So that was, actually, you know, I can find out fairly easily just by doing another factor analysis of just addiction. Here we go. Comes out as 2. And here's the pattern matrix right here. 5 and 10, things are reversed. So I'm going to take those out. 5 and 10. I assume they were reversed. I can look at the labels right here, actually. Okay. Here we go. I spend much of my time using it, and all I want to do is use it. Oh, those aren't reversed. Oh, well. Bummer. That didn't work. Okay. Oh, I was looking at the wrong ones. That's my problem. Wasn't it? Oh, where'd it go? Where'd it go? Right here, these ones. No, that was right. Okay, yep. They're not reversed. Those ones. Oh, well, let's run this again. We came up with 1. That is unexpected. So let's run a Cronvex alpha on it. Throwing all of them in. Statistics if item deleted. And here we go. So we came up with a 688, which is not what we want. The best thing we could possibly do for this scale is remove number 10. It'll jump our convex alpha up to a 759. Let's start with that. Run it again, get rid of number 10. And it jumps it up to a 759 as predicted. Now the next best thing we can do is get rid of number 5. Let's do that. And these are reflective. After having looked at those items, those are reflective. 8, 2, 9, that's way better. All right, anything else we can do to improve it? Not really. So now let's run it with those items and everything else back in. Factor analysis, those items. And then you said urge, right? And what were the other ones? Sorry. Isaac. You might be muted.
Self-efficacy and satisfaction.
Thank you. Satisfaction and self-efficacy. We actually didn't throw that in last time, but that's all right. What did we throw in last time? Problematic use. We can use self-efficacy. Here we go. Let's see. Self-efficacy. And run it. And still comes out with 6. Good mess. Lower redundant residuals. Here we are. It still looks cleaner though. Okay, here's addiction. It loads together. Not beautifully, but it does load together. And it cross-loads pretty bad on urge. Let's look at urge. Look at all the cross-loadings on urge. There are 2 here, main ones. We might do an EFA with just those 2. Self-efficacy breaks into 2 clean factors. Interesting. Oh, you're right. I have both in there, numbered differently. Cool. So the next thing I would do is, instead of just dropping addiction 6 and addiction 1, is I would do an urge and addiction factor analysis. Get rid of all that. Here's urge and addiction, and zoom out. Sorry if this makes you dizzy when I'm all zoomed in. And it came out with 3. Not what we were expecting. Pattern matrix, here it is. Urge 1 and 2 belong somewhere else. Let's start there. Urge 1 and 2. And if I were doing my due diligence, really I would go read those items and find out what they're really about, and then I'd make a better decision. But right now I'm just zipping through. Okay, now it's down to 2 things. Let's go to the pattern matrix. Here it is. Oh, no, that's not the pattern matrix. Hopefully. There it is right there. Addiction 6 loads more strongly on the other factor. Drop that one, addiction 6. Hey, that's looking a little better. Almost good enough to move forward with. You have these low loadings here, but and it's not like they're 0.3s. I don't like less than 0.5. We have enough to work with. They are reflective. I'm going to go ahead and drop 2 more right now. Addiction 1 and addiction 3. I'm also going to look at the loadings matrix. Did I say 1 and 3? And rotation. Loadings plot. Stop tapping me. There we go. Okay. Here we go. 2 factors. Good. Pattern matrix. Look at that. All right, it's separating things. We have 3s now, 4 and 8, and then we'll be left with 3. Let's see if that does it. 4 and 8. I didn't even look at the loadings plot. Whoops. Getting close. Varimax might fix that. Let's look at the loadings plot real quick. Oh, look how separated those are. So separate. Except urge. Urge is good. Urge is solid. Addiction is a problem. Yep. But we got closer. So we ran that factor analysis again, but with those other things back in. It was self-efficacy and satisfaction, I believe. Satisfaction and self-efficacy. And we end up with 4 factors. Hey, that's what we were expecting, right? Finally. Look at that pattern matrix. Whoa! Magic. Hey, that actually worked. Huh. There's a class here. Hello. Sorry, I've been in my own little world for a bit. Sorry. Yeah. So, hey, you're awake at least. That's impressive. Yeah. Hey, it worked, Isaac. Woo!
That's great.
Take a screenshot. Sorry. At this point, no. So the question was, am I worried about addiction 9? The answer is no, because these 2 loadings are so nice and high. Also, I only have 3 items. So to remove another item might cause instability issues. Yeah, our N is really good, I think. What's the sample size on this?
Around 200. It's slightly lower than 200.
Decent, not great, decent. What we might try is swapping out addiction 9 with addiction 1, addiction 2, addiction 3, and just seeing which one loads best. Yeah, it's kind of fiddling and playing, but you're just trying to get good measures. So why not try your hardest to get good measures? Yep. What we'd have to do now, we'd have to go look at these 3, 2, 7, and 9. See, are they really capturing addiction or is it something else? Yeah. Yep, we're just exploring. Cool. All right. Isaac is crying. Yay, that's my goal. Make my students cry. Okay. Doctor, how do you get the pattern matrix to show? I keep missing that in each I run. I'm missing something previous to check. You can go back and watch the video and see all those little check boxes I make. Hit pause if you have to. It is all there. Okay, I'm going to close this. Isaac, you got this on recording, so you're good. No on that. Close that. Check this. This is yours. Okay, we have 30 minutes left. There were a couple things extra. So potentially to have a better EFA, your recommendation is to ask at least 5+ questions. Just in case we end up removing them. Yes, if you're designing your own survey and you've never collected data on these survey questions before, because they're yours, they're new, I would strongly recommend having a minimum of 5 questions per construct, as it is strong possibility that you'll have to drop 2 of those. Pre-testing, pilot testing can make it so you don't have to drop any. If you're really good at foresight, thinking ahead, looking ahead, but even the best of us, sometimes we design questionnaires that make sense to us and don't make sense to anyone else. Okay, let's go back to the slides here. And extra time. Saving factor scores. Oh, I do want to show you that. I talked about it, but we didn't do it. Second order factors, we did that. Cluster analysis. Just quick show of hands. If I were to pick between cluster analysis and just sitting with you one-on-one, which would you prefer right now? Oh, sorry, cluster analysis, one-on-one. Nice, all right. One-on-one was a little bit more, so. All right, we'll do some one-on-one. If you want cluster analysis, go to YouTube and search for, or actually go to the StatWiki and go to cluster analysis on the left. And I have made a few videos on cluster analysis. So go and check them out. I literally went and learned cluster analysis and then made a video. So I might say some really stupid stuff in these videos, but at least I'll show you what to click and sort of what it means and how to interpret it and what's meaningful and what's not. But I'm sure someone who's a master in cluster analysis would just cringe at my videos. So it's a way to profile. So it's a way to create profiles of respondents. Cluster analysis says, how are these people the same as these people? How are they different? How can we group? It's big in marketing and consumer research. You have a bunch of customer data. Now let's group those customers based on that data. And now from there, what can we do with those profiles, with those clusters? Different kind of like targeted advertising and targeted promotions. Please make me sure if I understand correctly, second order can only be formative. No, second order can be reflective. You can have a second order reflective. Detmar Straub wrote, or was thinking about writing. I met with him and he showed me a paper. I don't know if it was a manuscript in progress or a published paper, but Detmar Straub had an idea, at least back in 2009, about the 4 different types of second order models. There's formative, reflective, formative, formative, reflective, formative, reflective, reflective. 2x2 matrix. And so you can have each kind, although some are less common than others. The most common would be a formative reflective, where it's formative at the second order, reflective at the first order. Okay. Well then, okay, so you're good. Okay. Wait, you didn't listen right now? Do I need to repeat myself? There's a paper with all the types listed by Detmar Straub. And if you stick a 2x2 matrix, formative and reflective, and cross them, yep, that's right, Detmar Straub. There you go. Cool. Great guy. All right. So then that's where I'm going to cut it today. I'm going to stop the recording and upload it to YouTube. And then I'll sit one-on-one with you guys. I have a meeting at 5 I have to run to, but it's just upstairs. So it's okay if I leave here at 5. And we'll be good. If you guys are done, you're done. You're welcome to mosey on. I strongly recommend 2:30. Yeah, I'll cover CFA tomorrow. For you local folks, I strongly recommend you escape and go do the stuff listed here. There's some awesome stuff to do in Utah. Go and do it. Have fun. Yeah, take your mind off all the statistics stuff. Oh, and not until you're done. Plow through it. All right. Different types of work strategies. Lucia says group hug. Okay. She would. All right. Let's see. Stop.